Today we will be taking the prime factorization of a number, so it's going to be extremely important at the beginning here to identify all of our prime numbers. So as we see here in front of us, we do have a hundreds chart. We're going to take this hundreds chart and we're going to identify all the prime numbers between 1 and 100. And remember, a prime number is a number that can only be divided by 1 and itself. So we'll start at 1. 1 is a prime number. Now there is some debate out there as to whether or not 1 is a prime number, but we're not going to get into that debate for our purposes, so we're just going to go ahead and say that it is a prime number. So we go to 2, and 2 is a prime number as well because you can only divide it by 1 and 2. However, we do know that 2 is an even number, and we know that all even numbers can be divided by 2, so there will not be any other even numbers that are prime. So we're going to go ahead and eliminate quite a few numbers here. So any number that ends in 2 is an even number, and that can be divided by 2. So we're just going to go ahead and eliminate anything that ends in a 2. A number that ends in 4 is an even number. So we're going to go ahead and eliminate this entire column of numbers that end in a 4. 6 is a prime number, or is an even number. So we're going to eliminate any number that ends in 6. 8 is an even number, so we're going to eliminate all the numbers that end in 8. And then any number that ends in 0 is also an even number, so we're going to eliminate all of those numbers that end in a 0. So we've gotten quite a few numbers off of our list here. Our next number is 3, and 3 is a prime number because you can only divide it by 1 and 3. Excuse me. 5 is a prime number, but we do know that we can divide anything that ends in a 5 or 0 by 5. So we've eliminated all of our zeros. So starting with 15, we're going to go ahead and eliminate anything that ends in a 5 because those can all be divided by 5. 7 is a prime number because it can only be divided by 1 and 7. 9 is not because you can divide it by 3. 11 is prime, 13 is prime, 17 is prime, and 19 is prime. 21 is not prime because you can divide it by 3 or 7. 23 is prime. 27 can be divided by 3 or 9. 29 is prime. 31 is prime. 33 can be divided by 3 and 11. 37 is prime. 39 can be divided by 3 and 13. 41 is prime. 43 is prime. 47 is prime. 49 can be divided by 7. 51 can be divided by 3 and 17. 53 is prime. 57 can be divided by 3 and 19. 59 is prime. 61 is prime. 63 can be divided by 7 or 9 or 3 and 21. 67 is prime. 69 can be divided by 3 and 23. 71 is prime. 73 is prime. 77 can be divided by 7 or 11. 79 is prime. 81 can be divided by 9 or 3 and 27. 83 is prime. 87 can be divided by 3 or 29. 89 is prime. And probably the toughest one on here is 91. 91 can actually be divided by 7 and 13. 93 can be divided by 3 and 31. 97 is prime. And then 99 can be divided by 9 or 11, 3 or 33. So the numbers between 1 and 100, all of the numbers that are not crossed out are the prime numbers between 1 and 100. Any number that we have crossed out is not a prime number, and it is actually known as a composite number. So the numbers that are left on the page are our prime numbers. The numbers we crossed off are our composite numbers. So our objective today is to express a composite number as a product of its prime factors. And so we're going to use those prime numbers that we identified in the previous slide, and we're going to break a composite number down into those. So 18 is known as a composite number because there are multiple ways to get 18. You can take 1 times 18 to get 18, you can take 2 times 9 to get 18, or you can take 3 times 6 to get 18. So 1, 2, 3, 6, 9, and 18 are factors of 18, and that's why it is a composite number, because it has more factors than just 1 and 3. So a composite number has more than 2 different whole number factors. Whereas 3, the only factors of 3 are 1 and 3. And so therefore it is a prime number because it only has those 2 factors. So 2 and 3 are the only prime numbers in the list of factors of 18. So if we wanted to, you could express our composite number as a product of its prime factors, which we would have right here. So you could find 18 by taking 2 times 3 times 3, because 2 times 3 is 6, 6 times 3 is 18. Or 3 times 3 is 9, 9 times 2 is 18. Excuse me. And that's the prime factorization, where we take it and break it down into its prime factors. And important to note that finding the prime factorization is not the same as finding the factors. That's a different lesson that we will do on another day. So one strategy that we have here from our young lady is to start dividing the number by its least prime factor and then continuing until we get a prime number. And we'll look at that strategy here in just a moment. So we want to express 60 as a product of its prime factors. And there are 2 general methods that we use in order to get that answer. Method 1 is a tried and true method that many of us have done before, and that's called using a factor tree. So you take the number that you are breaking down into its prime factor, so in this case it's 60, and then we're going to branch that off, and we need 2 numbers that when we multiply them together give us 60. So we could take 6 times 10. And since 6 is not a prime number, we're going to break that down. And to get 6, we take 3 times 2. So 3 is a prime number, 2 is a prime number, and so we can stop there. 10 is not a prime number, so we need to break that down. And to get 10, you take 5 times 2. 5 is a prime number, 2 is a prime number. So to get 60, you can take 2 times 2 times 3 times 5. And I'm okay with you putting that in any order. So if you wanted to write it in the order that you had it, and wrote 3 times 2 times 5 times 2, that is okay. And no matter how you break 60 down into its prime factors, you would still get 2 2s, a 3, and a 5. Our second method is called a factor ladder. And with our factor ladder, it looks similar to upside down division. And so just like the young lady told us in the previous slide, we can start by dividing by its least prime factor. Well, 60 is an even number, so we can divide that by 2. 60 divided by 2 is 30. 30 is not a prime number, and we can continue to divide that by 2. 30 divided by 2 is 15. 15 is not a prime number, but however, we cannot divide 15 by 2, so we look at our next prime number, which is 3. And we can take 15 divided by 3 to get 5. 5 is a prime number, and we do stop. One thing that you want to make sure you do with this method is that the only numbers you put off to the side, make sure that they are prime numbers. So 2, 3, 5, 7, and on up. Do not use composite numbers. So yes, we could divide 60 by 6, but 6 is not a prime number, so we don't want to use that. And just like we got before, if we break that down, it's once again 2 times 2 times 3 times 5. So now if we take 48 and we use kind of that same idea to get 48, if we use our factor tree, we just need 2 numbers that when we multiply them together give us 48. Well, 4 times 12 is 48. Neither of those is an even number, so we break that down. 4, we get 2 times 2. Those are both prime numbers. 12, you could do 3 times 4. You could do 6 times 2. Either of those would work. 3 is a prime number, 4 is not. And for once again, we get to times 2. So to get 48, 2 times 2 times 2 times 2 times 3. 4 2's and a 3 in your answer. Or you would use a factor ladder. 48's even, divided by 2 to get 24. 24 is even, divide that by 2 to get 12. 12 is even, divide that by 2 to get 6. 6 is even, divide that by 2 to get 3. 3 is a prime number. Excuse me. And once again, you get 4 2's and a 3. And that is how we do our prime factorization. I hope you found this video helpful. And if you have any questions, feel free to ask.